Lily, what are we doing today? And would you all agree that you can now calculate compound probabilities?
Yes.
Compound events would be two events taking place. We call them event A and event B. Dependent events, events that depend on one another. And then independent events, we had in an earlier lesson, events that really don't depend on each other. They have nothing to do with each other, right? An example of an independent event would be rolling a number cube, picking up the number cube and rolling it again. Does my second roll have anything to do with my first roll? Yes or no?
No.
So that's an independent event, right? Okay, if I had an orange and an apple in a bag, and I closed my eyes and reached in there and picked the orange out and left it sitting outside the bag, and closed my eyes and reached in there and picked the apple out, would my second draw have anything to do with my first draw?
Yes.
Obviously, because the orange was gone, right? Okay, so that would be a dependent event. Mutually exclusive events, events that cannot happen at the same time. Inclusive, they can happen at the same time. What is this? And again, I'm not going to talk much about this in our video notes, so when you're listening to me, when you're preparing for the final test, when you see that the probability of independent events is the probability of A times the probability of B, you know that this is simply the what? Everybody.
Fundamental counting principle.
Which states that the probability of event A times the probability of event B, which is exactly what you see here, is going to give you your total probability. As opposed to doing the fundamental counting principle, what was the other way you could calculate probability in those situations? So instead of using this, what is the other way of calculating probability? It takes a lot longer. We did it way earlier in the chapter.
Oh.
Andy, what is it? A tree diagram. So is this an important thing to know?
Yeah. Yes.
My pre-algebra kids, the question that Matthew P. asked today, you can even ask them, why did they teach us the fundamental counting principle in 5th grade? I just taught them today. Again, you want to see there's not a whole lot of difference between the two classes. I just taught those guys the fundamental counting principle today, and they're like, that would have made life so much easier because they've been using tree diagrams to calculate probability. Are you using tree diagrams to calculate probability? No, you're using the fundamental counting principle now, aren't you? Could you use a tree diagram if we asked you to?
Yeah.
Yeah, you can make one of those. Dependent events, really important again that you know that if they depend on one another, it's the probability of the first event, Annika, times the probability of the second event, but only after you eliminate what happened in the first. So that's that orange apple example that I just gave you. There's a lot of stuff going on here, so I hope we're listening and paying attention. Okay, example from a deck of cards, and then the mutually exclusive and inclusive events. We gave a couple of practice problems, A, B, and C, and then we did some practice here. I'm going to skip down to number 10. I'm sorry, number 11. And here you go. You have a deck of cards with one draw. What's the probability you're going to get an ace and a king? You can't get an ace and a king if you have one draw. What's the probability you get an ace or a king? 15%, a huge difference, right? You can't get an ace or a king in one draw. It's impossible to get that card in one draw. It's impossible to get both of those in one draw. It doesn't even make sense. Therefore, at 0%. But you could get an ace or a king if you substituted the word and out and put the word or in. Any questions before I stop?